Hello and welcome back to section 1.7, where we're going to be talking about the properties of real numbers. Now that we know how to add, subtract, multiply, and divide, we can now discuss some of the properties, the laws that form algebra and mathematics. And so let's go ahead and get started. The first thing that we want to talk about is to make sure what we really know what it means when we write an equal sign. When we write an equal sign between two expressions, for example, 3 and 12 over 4. Those are equivalent expressions. They're equal, and we use the word equivalent to express those expressions. Here's another one that we can discuss. For example, 5x over 10 and x over 2. These are equivalent expressions because we can take the 5 and cancel it with the 10, leaving us with just 2. So we want to make sure that we understand what equivalent means as we start moving into talking about the laws of real numbers. So the first one we want to talk about is a plus 0. A plus 0 will always equal a. Okay, when we add 0 to any number, this is called the additive identity. The additive identity. And this basically tells us that 0, you can add 0 to any number, and you will get that same number out. There's also a multiplicative identity. Anybody know what a multiplicative identity? A times what will get me a? Multiplicative identity. Multiplicative identity? You got it. The multiplicative identity is 1. Because 1 times any number will always give you that number. So these are the identity properties that are important to know. For example, we could even give you another question talking about this. What if I gave you the fraction 2/3 and I said, write an equivalent fraction that would give us a denominator of 9x. So basically, I want you to find this top value when we do 9x. Well, the multiplicative identity allows us to multiply any number by 1 or its equivalent. So for example, if I wanted to get 9x here, we could multiply the bottom by 3x. Doing 3x times 3, well, that's 9x. However, you can't just multiply the bottom by something. You have to also multiply the top by something. So we would also multiply the top by 3x, and that would get us 6x. So again, this idea of multiplying something by 1, 3x over 3x, that's just 1. But we can do that to create equivalent expressions. So now it's your turn. Let's have you take out your video notebook and use the multiplicative identity. Multiply this fraction by some factor of 1 so that you get the new denominator. So on this first one we have 6/7. We want you to rewrite this fraction so it has a denominator of 14y. And then on number 2 we have 3/5, but we want you to rewrite that fraction so that it has a denominator of 20xy. Go ahead and pause your video and write that down in your video notebook, and then we'll discuss it. Okay, good. So again, remember, you can multiply any fraction by a factor of 1. And that 1 could look different. So if I wanted to get 7 to be 14y, I need to multiply that by 2y. So I multiply the top by 2y and the bottom by 2y. And here I get 12y. Same thing down here. To go from 5 to 20xy, we're going to have to multiply by 4xy. If I multiply the top by 4xy, then we're going to get 12xy. Excellent. Great work. So we discussed about the identities. Let's move on to two other laws, the commutative law and the associative law. The commutative law states that if you have some number, a, and you add it to another number, say b, then you can switch the order of that, and it's going to be the same. It would be b plus a. This is true for any real number. These are real number laws. So if I took 5 plus 3, that is going to be the same as 3 plus 5. This also works in multiplication. So if I had a times b, that's going to be the same as b times a. So again, if I had 7 times 2, that's the same as 2 times 7. This is an important law because it allows us to realize that under addition, that we can switch things back and forth. The order does not matter. In associative is kind of the same idea. In the associative laws, we have 3 groupings, 3 or more groupings. So for example, if I had A plus B plus C, and I wanted to add A and B first, I could do that. And that would be the same as if I took A plus B plus C and added B and C first. Again, we could prove this with real numbers. 2 plus 3 plus 4 is going to be the same as 2 plus 3 plus 4. Doesn't matter the order we do it. We could add the 2 plus 3 first or the 3 plus 4 first, and we would get the same answer, which is 9. This also applies to the multiplication rules. We can do A times B times C and do the B times C first, or we can do A and B first and multiply those. So I could do 3 and then 5 times 2, or I could do 3 times 5 and then times 2. We know that this is true because of order of operations. That's one of the rules. And then also that these are laws, and laws can be applied throughout the world of mathematics. Okay, so now it's your turn. Here's 3 problems. What we'd like you to do is use the associative laws and the commutative laws to rewrite an equivalent expression. Some equivalent expression for these problems here. Take out your video notebook, push the pause button, and write some different way of writing these that would get us the same answer. You can push play when you're ready to resume. Okay, how do we do? So again, we're using the commutative law and the associative law. So if I wanted to do this with the commutative law, basically x plus 5, that would be the same as 5 plus x. All we have to do is switch those. The commutative law says that there is no problem if we switch those. In fact, they are equivalent. They are equal. Same with number 2. We can just switch the order. We could have written something like this, 8xy. You could have even got creative and done something like 8y times x. There's no problem in that as well. So basically, it's just rewriting the order. Under multiplication, we are allowed to apply the associative rule and change the order. Same here under number 3. Number 3, we can do the 6 plus x first. Since it's addition, it doesn't matter the order that we group things and that the grouping order that we do it. The last law that we need to talk about today is the law called distribution. It basically states that if we have a number being multiplied to a quantity of 2 other numbers, b plus c, then you can distribute, you can multiply this in. The a is going to be multiplied to everything inside, and that's going to leave us with a times b plus a times c. This would be true for anything. So, for example, if I had 5, and I had x plus 2y plus 7, and it's going to everything inside the parentheses. Doing that, I would multiply the 5 to everything inside. So 5 times x is 5x, and 5 times 2y is 10y, and 5 times 7 is 35. The distribution law. But we multiply that value to everything inside. Okay, it's time for you to demonstrate your knowledge of the distribution law by distributing each of the values into the parentheses. So multiply these out so that you have no parentheses left over. Go ahead and pause the video, work on these on your video notebook, and when you're ready to check your answers, push the play button. Okay, let's check those answers here. Again, I would multiply this 3 into both values inside the parentheses. So 3 times x is 3x, and 3 times negative 7 is a 21. 3 times 7 is 21, and we'd have a minus there. So that's how we would distribute that. Here we have 3 things to distribute into. 4 times 2x is 8x. 4 times 3y is 12y. And 4 times 1 is 4. That's how we would distribute those. In this last problem, we have a negative to distribute in. Now remember, we are gonna take the whole value. We are gonna distribute the entire negative in. So we distribute the negative 3 in, and we're gonna get negative 15x. Notice that our signs inside the parentheses are gonna change. I then distribute this negative 3 in here, and it's a negative 3 times negative 2, which really makes this become positive 6y. And then a negative 3 times a negative 4, well, that's going to make it plus 12. So notice that when we do distribute a negative in, all the signs of the terms inside do change. Please note that these are all called terms, and so that you do realize that when something is separated by an addition or a subtraction sign, those are called terms. So 5x plus 9y plus 1 has 3 terms. The term is 5x, the second term is 9y, the last term is 1. Okay, the next thing we want to talk about in this lesson is factoring. Often we want to factor problems. Factoring is basically undoing. For example, if I was to give you this problem here, 5 and 2x plus 3, we know that we can distribute the 5 in. So it's we would get 10x plus 15. Now, if we were given this problem and we were told to undistribute this problem, how would we do that? Well, you want to look at each term and decide what is the greatest common factor in each of these terms. In other words, we would look here at the 10x and we'd say, okay, what goes both into 10x and into 15? What could we pull out? And we look at that and we say, whoa, we could pull out a 5. 5 goes into 10 and 5 goes into 15. So we would pull a 5 out of both of these. And when we pull a 5 out of 10x, we would divide that out, leaving us with 2x, and we would divide the 5 out of 15, and that would leave us with 3. So that's how you factor. Basically, it's going from, it's undistributing. Let's try a couple more of those. What if I were to give you this problem here? 18x plus 12. What if you had to factor this problem? So again, we'd look here at both of these terms and say, okay, what goes into 18x and what goes into 12? And hopefully you realize that it's 6. And so we're going to pull 6 out of both of these. Divide a 6 out. So if I took 18 and divided it by 6, we'd be left with 3x. If I took 12 and divided by 6, I'd be left with 2. And that would be our distribution. Our factoring. And you can distribute it in to check your answer to make sure that it works out. Let's look at another one. What if I had a 4x plus 20y minus 2? And we were to ask to factor this problem. So as I factor this problem, I want to say, okay, what will come out of this term, and this term? Hopefully you look at that and say, oh, they're all even numbers. We're going to pull out a 2. 2 is the greatest common factor. So as I pull out a 2 out of 4x, we would divide. That leaves us with 2x. As I pull a 2 out of 20, 20 divided by 2 is 10y. And as I pull out a 2 out of 2, 2 divided by 2 is 1. And we would be left with that answer. That's how we do factoring. It's undoing the distribution. Let's have you guys do some practice problems. Okay, so here are 4 problems for you, and we would like you to factor these problems. In other words, you're going to look at each term and decide what you can pull out from each term and then divide it out. Go ahead and pause this video and give these 4 problems a try, and when you're ready to check your answers, press the play button. Okay, here we go. We are going to pull out some values here. I look at this one and I say, ooh, I've got a 15 and a 9. What will go into both 15 and 9? Hopefully you found out that it was a 3. So we would take a 3 out and then divide that out of each one. 15 divided by 3 is 5x. And 9 divided by 3 is 3. And so that would be our answer there. On number 2, I'm going to look at, we've got 3 terms, and I say, ooh, okay, we've got a 12, a 6, and a 30. Now, 2 would have worked. If you pulled out a 2, note that you would have been left with 6x minus 3y minus 15. However, However, notice that if I look at this problem some more, I realize that there's more that could be pulled out than just a 2. So when you do that, try to get the greatest common factor because you do want to simplify all the way. Really, you should have pulled out a 6. Pulling out a 6 would have got us 2x minus y minus 5. That would have been our answer there. If you just pull out a 2, you need to realize that you can factor out more. You could actually pull out a 3. On number 3, we've got an a in each of these, so we could just pull out the a, leaving us with x minus y minus z. And lastly, here for number 4, we have 2 terms, and the common term is actually 1. Notice that the 3's are the same, so it's actually 1/3 is the common factor that we can pull out. If we pull out 1/3, that 1/3's gone. We're just left with x because we're dividing. 1/3 divided by 1/3 is 1. And if we do 2/3 divided by 1/3, we're left with 2y. That's our answer for number 4. The last thing we need to talk about in this section is combining like terms. When we do addition and subtraction and things like that, a lot of times there are terms that we can add. For example, if I had 5 star plus 3 stars, well, we can combine that. That would be 8 star. Okay, and you can do this with all kinds of symbols. If I had 9 smiley men minus 5 smiley men, well, you would tell me that we have 5 smiley men left. We can do 11 winky men, and I can subtract that from 16 winky men. Okay, and we get -5 winky men. The same is true with variables. If I had 8x plus 3y, we can combine those. 8x plus 3x, we can combine those and get 11x. The issue is that you cannot combine things that are not alike. We cannot combine 8x plus 5y because this is x's and this is y's. It's just like apples, bananas. You can't say I've got 5 apples plus 3 bananas equals 8 apples. That's not true. I guess you could say it equals a smoothie, but that changes everything. That's not what we're dealing with here. So please realize that as you are doing problems, you cannot combine them. Well, a very common error is this one here. If I had 3 smiley faces plus 5 smiley faces with a hat, can we combine those? No, they're not the same. And so a lot of people confuse 8x plus 2x squared. You cannot add these. X is wearing a hat. Okay, so do be aware of that. They've got to be exactly like terms to be able to combine them. So as an example here, if we had 13x minus 4 plus 2x plus 7, we can combine the x's because they are like terms. We can combine 13x and 2x to get 15x. We can also combine the numbers. Numbers by themselves are like terms. I have minus 4 and plus 7. That gets me plus 3. Down here we have an 8y minus 6y. Well, that leaves us with 2y. And we also have a minus 2z. It doesn't have anything to combine with, so we just write minus 2z. This is an example of combining like terms. Let's have you try 3, and then we'll be done with the lesson. Okay, try these 3 problems here. The third one's kind of a challenge problem. We're going to combine everything you learned in the lesson and see how you do with it. Go ahead and try those. Pause the video, and when you're ready to resume to check your answers, push the play button. Okay, time to check. Here we go. We've got 6x minus 8x. Now, that's 6 minus 8, so that's going to leave us with a negative 2x. Here we have negative 7 minus 2. That's minus 9, so that's what you should have worked out there for the first one. Here we've got a's and b's, so we're going to combine our a's. 13a minus 5a leaves us with 8a left. Here we have 9b minus 4b. That leaves us with 5b left. On the third problem, you're going to want to distribute first. We're going to distribute the 2 into the parentheses. And that's going to leave us with 2x plus 5 plus 2x plus 6. We then can combine the like terms. We can do 2x plus 2x leaving us with a total of 4x, and a plus 5 and a plus 6, leaving us with 11. How'd you do? Great work. So that's combining like terms. That's how we do that. Hello and welcome to section 1.8. Today we will be discussing negative distribution and how to simplify expressions. Now, before we get started, I posted 2 letter grades. Now, one letter grade probably excites you. The other's probably not too exciting. An A+. Yeah, that's what we hope you'll aim for in this class. Remember that you can get tutoring help, and you can retake tests to continue to improve your score and better your understanding. Make sure to take advantage of that. If you have any questions about that, talk with your teacher or with a tutor. They can help out. Now, I also posted a B+ here. Now, B+, those aren't that exciting, but there is one place where B's are important. In fact, President Hinckley talked about that, and maybe not in school. We don't want you to aim for a B+, but there are some B's that are important. Take a listen to this quote right here.
Tonight, I'm going to let your teachers give you the A's that I hope you earn. I want to talk about some B's. You get the A's, I will give you the B's. 1, be grateful. 2, be smart. 3, be clean. 4, be true. 5, be humble. 6, be prayerful.
I'm so grateful for Latter-day Prophets who guide us in these days. President Hinckley gave us some important B's. Now, these aren't B's you're going to get in class, but some B's that you should apply to your everyday life. He said, be grateful, be smart, be clean, be true, be humble, be prayerful. In fact, be prayerful is really important. In fact, before we get started with the math, we'd encourage you each day, each lesson you do, to pause the video. Make sure you offer a prayer, because prayer is a great way to receive comfort and calmness and to receive the Spirit from our Heavenly Father. With that said, let's get going so that we can get you some A's. You guys can work on the B's, but we need to get you some A's right now. So let's get to the math. Now, just a little warning, what I'm about to show you here is one of the number 1 missed issues in algebra. This is one of it's like the top 3 mistakes that students make when working in algebra. We've talked about distribution and how you can distribute a value into the parentheses. Okay, so for example, in this first problem, we can distribute a negative in. Which makes sense. You distribute the negative in and you get negative 5x minus 2. But for some reason, when all of a sudden we switch the problem and we look at this example here, this is the exact same thing. Notice there is a negative right here. All I've done is place a 3 in front. For some reason, the common algebra student will forget to distribute this negative into both. They'll only distribute it into the 5x and not to the 2. But the problem is the same. We would write 3 minus 5x minus 2 because the negative distributes into both. And so then we can combine like terms. There's nothing to combine with the x's, so we just write those there. And then we have 3 minus 2, well, that's 1. So please realize you must distribute the negative. Okay, the negative goes to everything inside the parenthesis. Everything inside. Then you can simplify. So let's look at one more example of this. Again, I have 3x squared minus 2 parenthesis x plus 4 plus 3. So as we were working on this problem, you're going to want to work on the innermost part of the problem. So that's here in the parentheses. And we're going to go ahead and distribute the 2. Now, the negative 2. Remember, the negative's got to go in with it. This is a negative 2 that we distribute in. When we do that, we get 3x minus 2x minus 8. That's important to remember to distribute that negative. The negative distributes to both of those, making both of these negative. Once you've done that, you can finish the problem simply by adding the like terms. Here I have a 3x minus a 2x. 3x minus 2x is just 1x. and negative 8 plus 3 is negative 5. And so this is our answer. Again, remember, this is one of the number one errors in algebra. Top 3 errors is forgetting to distribute this negative. Don't forget, the negative goes to everything inside. Okay, let's give you guys some problems to work on. Take out your video notebooks and try these right here. Okay, here are your 2 problems. Like I said, pause the video and give these 2 a try. When you're ready to resume, go ahead and push the play button. Okay, let's take a look at these. Here we have a negative 2 that needs to be distributed into the parentheses. Remember, we take the entire thing, negative 2, and distribute it to everything inside the parentheses. So we get 4x minus 2x minus 6. Again, both of those signs become negative. You then can combine your like terms. 4x minus 2x, well, that's just 2x minus 6. That's what you should have got for the first one. Now let's look at this second one here. Hopefully you had some luck. I'm going to go ahead and start with distributing the negative 3 into the parentheses. When I do that, I get 2x minus 4y. I'll just rewrite that. Negative 3 times 7 is negative 21x, and negative 3 times negative 2 is plus 6y. Notice that the negative times a negative turn it into a positive. We then can combine the like terms. 2x minus 21x is negative 19x, and negative 4y plus 6y is plus 2y. How'd you do? Hopefully you did well. Let's go ahead and try 2 more, a little harder. Or actually, let me do an example of a hard one, and then we'll give you guys some additional tries as well. So take a look at this one. This one is quite brutal. It's got some additional grouping sets. Notice that we have parentheses, but we also have brackets. Again, when attempting a problem like this, you always want to start with the most inner part of the problem. Try to get as far inside as you can. In this situation, it would be with the parentheses. So we'd want to start there first. Let's go ahead and distribute the 4 into both of these parentheses. We get 4x plus 12. Now that we've distributed the 4, there are no more parentheses there. Okay, we do have these brackets. And I have a minus, and I'm going to go ahead and distribute the 3 in. And when I do that, 3 times 2x is 6x, and 3 times negative 4 is negative 12 plus 1. The next step then would be to work with the brackets. We eliminated the parentheses. Now we can work inside with the brackets. I'm going to go ahead and combine the like terms here. 12 plus 7 is 19. So I have 4x plus 19. And then I'm going to minus what's left here, which would be 6x minus 11. 6x minus 11. Now remember, it's minus all of this. So we do need to remember that this minus distributes into both of the values inside the parentheses here. So we're left with 4x plus 19 minus 6x plus 11. Notice this minus goes to both of these inside. When I do, now I can combine the like terms. 4x minus 6x is negative 2x, and 19 plus 11 is 30. Okay, that was a little more intense because it has 2 grouping symbols. Okay, your turn again to try these 2 problems here. There's one in green and then one in blue. Go ahead and pause the video, give these a try in your video notebook, work through them, and then go ahead and resume the video to see how you did and to correct anything you might have done wrong. Okay, here we go. Let's give this a shot. I'm going to start off with this green one first. It's a little easier just to kind of get us started. So I would distribute the 5 into both of these parentheses. I get 5x minus 35. I then am going to distribute the negative 3 into both parentheses. Hopefully you remembered to take the negative into both of these terms. So you should get negative 3x minus 9. We then can combine the like terms. I've got 5x minus 3x. Well, that's just 2x. And negative 35 minus 9. Ooh, don't forget, you can use a calculator if you need to, but this is negative minus a negative, so you're going to be more negative, which would be negative 44. Good. Let's try this last one here, this one in blue. I'm going to go ahead and distribute into the parentheses. So 6 4x plus 24 minus 12 is my brackets. I then am going to distribute into the parentheses here, and I get 4x plus 8 plus 3. Okay, I'm going to go ahead and combine the like terms here. 24 minus 12 is 12. I'm also going to go ahead and distribute this negative into both of these. You could combine the like terms first, and that's fine. But you could also just distribute that negative in. So I'd be minus 4x minus 8 minus 3. That's another way to do it. I get 6x minus 4x. That's 2x. And 12 minus 8 minus 3 is plus 1. How'd you do? Hopefully you did all right. And that sums up the chapter as well. So good work. Feel free to proceed on to this lesson, the online assignment, by pushing the start button at the bottom of the page. Finish that assignment, and you'll be done with the chapter. Be able to get ready for this chapter 1 test.